Hey, Calculates, got this just done just in time so that when you got home from the football game tonight, you could take your notes. Because I'm sure you're doing this on Friday, right? So we're going to keep exploring this whole idea of finding the maximums and minimums. And we've been noticing some new things about our graphs based off of whether we're looking at first derivative, slope of the original, or second derivative, slope of the slope, or concavity of the original. So collectively, all those maxes and mins are called extrema. And of course, we can talk about them in terms of where they are in the graph. Some of them are the absolute max and mins. Collectively, we tend to use loosely relative or local, meaning it's within a specified domain set. So, some steps that we want to do with this whole second derivative. So look who's here to work with us tonight. Calculus. Calculus is back, aka Patches. So he loves doing extrema. Okay, so on these extrema, if I find the first derivative, remember, using second derivative, I can test for concavity, whether it's concave up. So if I have an extrema, I can tell whether it's a max or a min based on the concavity for that point. So I'm going to use first derivative and then test it in second to find the critical points, and then use second derivative to test the concavity. So Patches says that when you find the critical points from first derivative, if you test it in second derivative and find out that in second derivative it's positive, then you'll know, oh, we're concave up at that spot, which means my critical point is a relative minimum. And at the same time, if I test my critical point in second derivative and I find out that the second derivative test is now negative, then my original function must be concave down at that point, and therefore, so concave down, and therefore my critical point is a relative max. And if when I test it, it ends up being actually equal to 0, test fails, and so I have to go back and use first derivative to test. And keep in mind that if first derivative is 0, or could be 0, or it'll be undefined, because I will have just used it to get the actual critical point. So the only way I'm going to be able to test with first derivative is to build my table. Okay, so again, a recap. I'm using the second derivative. I find the critical values first by using first derivative. Calculus just went away. I guess he got bored with maximums and minimums. He said they were too easy. And then I use the second derivative test to test concavity on those points. Of course, I don't have to do this. I could still just use my first derivative test and make the little table and see what's happening either way. This is just another tool in your tool belt.